Welcome to math! Our first problem for the dev project was involving a story problem on Five Nights at Freddy's 2 involving the character Foxy, who jumps at you before stuffing you into his suit. We made it so that Foxy jumps twice, originally starting at 5 and then at 2 before leaping 10 meters at you. And then we asked the reader to graph Foxy's approach as well as his domain of his jump. And because we know that the door is the 0 point, from what we could tell, you know the x-intercepts are -5, -2, and 8. From this, you're supposed to graph this equation showing you that Foxy only jumps downward because he is a robot and does not fly upwards, which would make the equation for this -1, x plus 5, x plus 2, and x minus 8. And therefore, the domain is how far Foxy jumped originally before stopping, so that would be -5 to 8, with closed brackets because he did not, even though he came from behind, that we only asked for his jump. For our second problem, we decided to do a factored form, and therefore gave you this equation. In order to solve it, you needed to use the diamond method to shrink it down to find 49x squared and -9x squared, which you would eventually solve here to get 5x squared minus 3 and 3x squared plus 9. Now, because these are squared on the inside, you can break them up further. 5x squared minus 3 becoming 5x minus 3 and 5x plus 1, and 3x minus 3 becoming 3x minus 3, 3x minus 3. Therefore, the x-intercepts for this become x equals 3 over 5, x equals -1 over 5, and x equals -1, which is shown right here as its domain. And then, this is the completed domain as -infinity, -1, closed brackets, u, closed brackets 3 over 5, infinity. And then its completely factored form is shown down here as 5x minus 3, 5x minus 1, 3x minus 3, and 3x minus 3.
Alright, so back to the game references. In Five Nights at Freddy's 2, you play as the security officer in the Five Nights building. So, to go along with the story, you have to find the area of the hexagon. So the shape is a hexagon, or the room is a hexagon, and you have to find the area of the hexagon-shaped room. So, to begin, take the hexagon, and you have to transfer it into a square to make the computing for the area easier. So then you can turn it into a square. So then the square has one length that's x and one length that's y. So that's step 1, to make it into a square. Okay. Step 2 is to use the area formula for the square. So the area formula for a square is x times y, or side times side. So then, to get further with that, we're given up here the perimeter of a square. So after we change it in the square room, the perimeter of that is 240. So then we have to use the perimeter formula so that this can easily go into the area formula. After we use the perimeter formula by putting in 240 for p, you get it equals 2x plus 2y. For step 3, after we use the perimeter formula, we try to single out the y. So by doing this, we have to get all their terms onto the left side with 240. So first, we subtract 2x, and that makes 240 minus 2x. Then we have to divide 2 so we can get y by itself. So then we do the whole thing divided by 2. And that, being simplified, equals 120 minus x equals y. So in problem 4, what we just got, so 120 minus x equals y, we put that in for the y up here. And so that's that right there. And so we have a equals x multiplied by the quantity of 120 minus x. And so after factoring this out, which would be trying to get the x's to equal 0, and the things are being multiplied or added or subtracted by. That would be, so this x right here would be 0, right here. And this x would be 120 because it's 120 minus 120. So that's the two x's right there. After finding those two x's, you have to find what's in between these two, so that you can get the side length of x back up on the square. So to do that, all you have to do is find in between. So in this case, 0 and 120, you just take 120 divided by 2, and that gives you 60 for x. So then you take this x, the side length up here, and you plug it in to this equation right here. So after plugging it in, you get the area for putting 60 in for x. You get the area of 3,600. After finding the area of the square, we have to take the area divided by the x length, so we can get the y length, which in this case is another 60. So the y and the x are the same. So we have x and y equals 60. So now we have our side lengths 60 and 60 down on our square here again. So now we have to take, after dividing the square into a grid to help us find the actual hexagonal shape area, which is what our intention is, we have to divide 60 by 3 because there are 3 square areas for each side length given. So that would give you 20. After finding 20, so 20 would be one side length of the square. So 20, after finding 20, that would be an individual side length of each individual square. So 20 and 20. And after finding the side lengths of each individual square in our grid, what we have to do is, because there's triangles there that we're trying to represent and not the entire square, individual square, we have to take 20 multiplied by 20 divided by 2 to get the area of the triangle. So here's the formula for the triangle. Triangle area equals x times y divided by 2. So in this case, x and y are 20 each. So 20 times 20 equals 400. 400 divided by 2 equals 200. And that is the area of the triangle. Oh. After finding the area of the triangle, each individual triangle, which is 200, what you have to do to find the area of the hexagon, you have to take 200 multiplied by 4 because there are 4 triangles, and then you have to take 400 because that's the for each individual square, that is what the area of those were, because it was 20 multiplied by 20. You have to take 400 multiplied by 5 because that's how many squares there were in the hexagon, and you have to add those two variables together. So in this case, the entire area of the hexagon would be 2,000, and we'll just put, say, square feet in here, just to give it a little more pizzazz. Alright, square feet. That is how you find the area of a hexagon. Hip hip hooray! Okay, so in this problem, we have a long division. So, long division is basically taking a long strand of numbers, in this case, 8x to the fourth minus 37x to the cubed minus 31x squared plus 74x plus 30. So it sounds pretty big, but it's manageable. So in this case, every time this happens, you're given the one x intercept because you need that. So x equals 5 in this case. So now we have to take that intercept and make it into a factor. So that would be x minus 5 because it's a positive 5 up here. So then you take this long strand of numbers and use a process called long division. So what long division is what I'm about to describe. Okay. So to begin, you take the x over here and take the first variable and divide it by x. So then you get your answer right here, 8x to the cube, or to the third. So then after using that, after finding that, you take it again and multiply it by x one more time. Sounds silly, but then you put that, which would just equal the same thing right here, 8x minus, or 8x to the fourth, back under the first 8x to the fourth. But in this case, you do a minus and you put this into a factor. So then, after finding this number right here, you have to take negative 5 and multiply it by that as well, which would give you negative 40, and you put that under the negative 37. Now what you do at this point is, since there's a negative at the base of the factor, you would just subtract it. So 8x to the fourth minus 8x to the fourth equals 0. And then negative 37x to the third minus 40x to the third would equal 3x to the third. That's your answer right here. After finding that, you just put that back up top, divide it. You can't forget to divide by x again. So you take your answers every time you get an answer down here after subtracting, and it will always be subtraction. You take that and divide it by x. So in this case, you get positive 3x to the squared. Okay. After finding that, what you do next is just keep going down the line. And so, and in this case, so after you find, in this example, 3x to the third, you drop the next number. So right there, you drop it, and you put it next to the answer. So 3x to the third minus 31x, and 31x is up here, right there. So then you just, again, you multiply x by your answer. So you do multiply, and not this answer down here, the answer you put up here. So x multiplied by 3x squared, which would give you, again, 3x to the third. And again, it's always subtraction. So you put 3x to the third inside a factor, and then you take negative 5 and multiply it by 3x squared, and you get negative 15x squared. So now, with the drop, which was negative 31x squared, you take 3 minus 3x squared, or 3x to the 3 minus 3x to the 3 equals 0 again, and you take negative 15 minus negative 31. So in this case, it would really just be like adding 15x squared to negative 31x squared. So then you get negative 16x squared. So now, again, after you get this answer right here, you take it and multiply it, or divide it by x, and put the answer up here. So you get negative 16x. So every time you solve for a variable, you just take away an x, essentially. In the next step, you just keep going down the line, consistently dropping the next variable inside the whole equation next to your answer. So negative 16x squared plus 74x, and then you just multiply x by negative 16x, so you get, again, negative 16x squared. Minus would basically be like adding, so this is 0. Then you multiply negative 5 by negative 16, giving you a positive 80x, and making that negative 80, or subtract 80 from 74, giving you negative 6x. So after you find the answer, again, divide it by the x up here, and then you get to put it up there as just negative 6, because x was divided out. Okay, ready and record. Okay, so where we were is we just came to the conclusion of, we just got the answer of negative 6, and we have to now drop the next variable, which is 30, and we have to multiply again, so multiply negative 6 by x, and you get negative 6x, and then you have to take and then you have to subtract negative 6x, which make this 0, and just by chance, of course, negative 5 multiplied by negative 6 equals positive 30. Positive 30 minus 30 equals 0. And this is what we want to achieve usually when these problems happen. If there's an extra remainder, like plus 30 here, it should, if it factors correctly, it should equal 0 down here, so that you don't have to add another variable up here. So that it did, it is factorable, and we can continue on to the next step. So yay! Yes. So the next step is taking what we just got. So we take this big strand up here, the new answer that we got, and we put it down here. So we got 8x to the third plus 3x squared minus 16x minus 6. And we now that has this pattern just by going x to the third, x squared, x, and no variable. That's it can be grouped. And what grouping is you just take the two numbers closest to each other in each on each side and put them together in a factor. So 8x to the third plus 3x squared in 1, and then negative 16x minus 6. And so now what we want to try to do is try to find a number or a factor, or a number or a variable that can be divided out of each of these parentheses to get each numbers inside each parentheses to match. So in this case, we'll start with dividing out x squared, we're making this 8x plus 3. And so now it's 8x plus x squared multiplied by 8x plus 3 multiplied by negative 16x minus 6. So now, after doing that, we divide out from this side negative 2, which would make it would make 8x plus 3 and 8x plus 3 match. So we have a match right here. And so now what you do, so we have a match down here. So what happens is you group these two matches together into one parenthesis, and then you put x squared, the outside numbers that we took out to find the matches, so x squared minus 2 into a parenthesis as well. So now we have x squared minus 2 and 8x plus 3. So after finding that, we can put back into the final equation. Up here, the x-intercept that we use to find the answers. So we have x minus 5. Put it back in as a factor. So we have x minus 5 multiplied by x squared minus 2 multiplied by x squared plus 3. And that is the factor form of the problem, the answer we want to achieve, and that is the final answer. And that is how you long divide and group a problem of a group of numbers in standard form. So we did it.
For the fifth question, we decided to combine all previous and use long division, factoring, and finding the domain and range. Now to do this, we set up an equation shown here, and we've given you one x-intercept to do long division, shown here. You do the normal steps of division, ending up in 0, so you have no remainders, and get x squared plus 12x minus 253. And over here, you can get it to this form right here. Now I'm going to pass it on to Ben, who will explain the rest of the problem.
Hey, what's up? Whoa!
This is my partner.
It's me in the house.
I picked him.
Let's learn some math. Whoa! Sorry.
Okay. We're on drugs. Just keep going.
Yeah. Okay. I'm gonna erase that though. Okay. So after finding this, this is still factorable. So what you do now is we have the x plus 2, which was used up here, and then we have to find or factor out the rest of this right there. So by doing that, you can do just the guess and check method, which just means finding two factors that can multiply to equal this big strand, or you can do my favorite method, which is called cubing and diamond method, excuse me. And so what that is, so you put x
Cubing! Cubing!
Okay, you put x squared. I can't fuck. Okay. Okay. So what you do is you put x squared, or the first variable, into this box right here, and then you put the last variable with no x's into this box right here. So negative 253. And now you multiply these two and put that into another diamond, which would be negative 253x squared. Now you take this number right here in the middle, negative 12x, and you put it down here. So now what we're trying to do is we're trying to multiply two numbers that can equal negative 253x squared, and also that can add to equal negative 12x. So in this case, negative 23x and 11x can add to equal negative 12x and multiply to equal negative 253x. So after finding those two numbers, you put 11x into that square, the empty that were previously empty, and negative 23x into this square right here. So now what we want to try to do is we try to find the dimensions, quote unquote dimensions of the square. So what that means is to find what numbers can be multiplied to equal these two and these two. So in this case it's pretty easy since this is only x squared. The only thing that these can be is x and x for this. So then you just do negative 23 and 11 for those, because then that would equal x multiplied by 11 equals 11x, and x multiplied by negative 23 equals 23x. So now that we find those, what you do is just put those in parentheses, and so you have x plus 2 and 1, x plus 11, which is right here, and x minus 23, which is right here. So after factoring completely, we have the three x-intercepts we need to try to find and plot the graph. So to find the x-intercepts, what you have to do is you just have to get x to equal 0. So x for this would be negative 2, x for this one would be negative 11, and x for this one, for this factor, would be 23. So now we go and plot that in the graphs. Negative 11 right here, negative 2, and 23. So now, looking back up here, this graph is a polynomial, and because it has an x, it has a cubed x up here, so that shows that it is a polynomial. Okay, so now after finding that the graph is a polynomial, we have to find what shape the graph makes by finding what how many x's. That just really sounds stupid. So after finding the factored form, what we have to do now is, after already knowing it's polynomial, we have to find what shape that the graph is. So to find the shape, we have to find how many x's, so there's only 3 here, are in the factored form. So there's 3. So this is an odd number. So this means that the shape is, as is shown right here, is a like an n. And since it is positive, since there's no negative in front of the entire factored form, it is positive, going up this way and going down infinitely that way. So now we find that we have to, the domain is any place that the graph is positive, so above the x-axis, which is right here. So in this case, what you can do is wherever the graph is above or equal to 0, you mark that in the domain. So the domain equals close bracket, which close bracket just means that it is equal to 0. So close bracket, negative 11, negative 2, close bracket, which is this area right here. And then u, which just means it's a unity, so that just there's nothing in between there until the next one. We have numbers, which is close bracket 23 to infinity, open bracket, which just means it goes on forever, which is this right here up until forever. So that is the domain right here, and that is the answer we're looking for. And the next part is the range, and the range is basically just the how far negative the graph goes and positive the graph goes, if it has any stop points. In this case, it infinitely goes negative and infinitely goes positive, so the range would just be negative infinity to positive infinity, both open brackets, because they don't have a stopping point. So that right there are your answers, and that we're trying to find the domain and range and the factor form, and that is a win for Team Math.
Thank you for listening.
Thank you for being an awesome listener. Hope you had a grand old time listening to our spiel.
You know when to start.
What do we have to do? Complete the square?
It's your problem.
No, start.
Okay.
Ah!
My parents are gonna think something is wrong with you more than
Just close bracket 23, so right here to infinity. Dude, it's supposed to be an open bracket. Okay, I can fix it.
Wait, what's supposed to be on the
Is it?
The infinity.
Where?
Yeah.
Did I not? Oh, I didn't. I'm stupid.
Well, that's why it's all fucking terrible. Okay, fix it.
Are these small bloopers gonna be in the end?
Oh, yeah, for sure.